Hello everyone, my name is Srinivas. I'm the full stack developer. In this session, I'm going to explain all the Java related concepts. So why Java, right? So Java is a backend development, and what is the purpose of Java? We will see. So basically Java stands in the backend, and let's understand what's the difference between front end and back end. So front end is something a user or a client can access from the browser. So when you open facebook.com or any website, you will see the web page, and there you enter the username and password. And once you enter the username and password, you need to check if it's valid or not. So when customer clicks on submit, the data is sent to the server, and from the backend, Java or any backend programming like .NET, they can verify if the user is available in the database or not. And you might be writing some different logics in the backend. Say example, uh, the password might be expired after 30 days. So if the user is logging in after 30 days, what backend need to do, you need to give a different page to update your password. And if the password is wrong, you need to send a different message, right? So all these backend related concepts we will be writing in Java. So Java is a programming language. Yes, because we will be writing some scripts and some logics, and it's a programming language. And we have two types of language, like high level and low level. So low level language is something system can understand directly, right? So if you type low level, emission level language, right, we got some assembly languages which system can understand. You need to write as a system understandable code. And whereas high level language is something developers can understand. If you see here, you write a Java program, and which you can understand by reading the statements, and that Java computer cannot understand. So for that, you need to compile that program into a object file or class file. So when you write a program in Java, you compile that and it gives the uh, dot class file, which is called bytecode. So bytecode is something which is understandable by computer, right? So what we need to do, our JVM or Java virtual machine can convert this bytecode into system understandable code. Okay, we will see that example right now. So here you can see I have a folder here Java, but nothing exists, right? So what I'll do, I'll open a file here, click on new, and I'll see text document, or you can open the notepad. I'll save this file, click on file, click on save as. So in the desktop Java folder, I will say hello.java. So make sure you give this extension .java, save it. So right now you can see a file is available inside this folder, and this Java file right now it's empty. Let me write a small program here. Alright, we will understand each line shortly, but I'm just trying to explain how the compilation and interpretation works. Alright, save this program, open. Now we have only one Java file, right, which we can understand by saying, hey, this is something like hello. It says print some statement like hello world. So now this one, how do we execute, and how computer can understand this code and give us the result, right? So let's see that. So open CMD here, and let's compile that, right? Java C dem hello world dot java, which is our file name. Press enter. So what happens if you minimize, you are seeing two files. One is .java, which is our file, Java file, and you see a class file. So class file is something which computer can understand now by which JVM can execute. Okay. So now let's see how I execute that program. Okay. Java hello, enter. So now it's printing hello world. Now it is printing hello world because whatever is written in this hello, it is executing, right? So who is taking that responsibility to convert our dot class file to system understandable uh, content, right? JVM is responsible. Okay, so that's why Java is a high level language where user can understand, a developer can understand, but system cannot. And to convert that, we need to use compilers and interpreters. We will see in deep what are compilers and interpreters shortly. And where Java is used, right? So Java is used in 800 plus millions of machines in the computer systems, right? In even in Android applications, even in big data, server side application, database applications. In most of the projects, we will be using Java. And now let's see what is Java history. So initially, the person who developed Java is James Gosling, and he's from Sun Microsystem. And you can see the versions every year from 1995. The versions are keep changing. Initially, we used to call Alpha, 1.0, etc. Now in 2021, we are seeing Java Standard 17 LTS. LTS stands for Long Time Support, and we will be using SE 17 version in this session. And in future we'll be getting as we are getting 22 in the 2022 we are getting 18 version, and we'll see how it goes on. And if you see in Java programming, what is the place of Java and how many developers are using this Java, right? In you can see the percentage. In lot of the projects they will be using JavaScript, HTML, Python, SQL, and Java is almost 35% we are using in real time. All right, so now we will see the features of Java. Why Java is so famous? Because of these features. So Java is simple, robust, secure, portable, multi-threaded, object-oriented, high performance, and scalable. We will see in deep what are these features shortly. Okay, now when we talk about Java, always the first question comes is why the Java is platform independent. When you have .NET programming, it is a platform dependent. So for example, Java is platform independent because you can write a program in one computer and execute in different machines like Mac or Linux system, which means you are writing a Java program in a .java file, and then you use Java compiler and convert that to the bytecode. And once the bytecode is available, you can take this bytecode and with the help of JVM, you can execute in any of the machine. So if I delete this .java, I can copy this class file into any of my machine and execute with the help of JVM. This is common interview question, why Java is platform independent, because you can write in one system and execute in any of the machine. Now let's understand JDK. What is JDK? JDK stands for Java Development Kit. So this JDK helps to build our application with the help of the programming. Okay, so to understand JDK, let's see one example here. Open your system, and in the PC you have the C program, C drive, and go to your program files. Once you have Java installed in your machine, you will see a folder here called Java, and inside Java you can see JDK. This is available only if you have installed the JDK in your computer. So once you have JDK, you open that and go to lib. Lib stands for library. So this library, you can see a file called src. You can see a file called src, and just copy this src and go to your desktop and create a folder. If you don't have one, I have created a Java folder. I paste it here. So just extract this, right click and extract here. So you can say extract all. So once you click on this extract all, you will see a folder called src. What this src contains, it contains a lot of folders. So whenever you install JDK, it gives all the tools that helps to build our application. For example, understand this diagram, right? So when you install JDK, you are getting a Java library, and in each library, you are getting some packages like lang package, util, net, awt. What are these packages? Packages are nothing but you can consider it as a folder. So all the language related classes, they are combining into a folder and they are mentioning a name for it. For example, you are writing some program related to network communication, right? So you want to chat with one person by using a network communication. So they have their own set of classes inside the .NET package. So if you see here, a few minutes back, where we have copied. Okay. Here, when I just go to, once I extract that src, you will see a Java base, open Java um, folder, and you can see there are lot of packages, whatever IO, lang, math. So whenever I want to write some mathematical related program, all the helpers are available inside this. You open that, you see a decimal, you see a big integer, things like that. So .NET package got all its classes. And what is a class, we will see shortly. Okay, so every package contains classes, each classes contains method. To remember this, I have given one example here. In real life, we have library. In a library, you imagine there are racks. Rack 1, rack 2, rack 3, rack 4. Each rack I will consider as a package. So each rack contains books, right? And book, remember, it is a class. And in each book, you get some chapters. Chapters are nothing but methods you can consider. So always remember, a package contains classes, classes contains methods and variables. We will see this shortly. Okay, so whenever I want to write some language related to print, to close something, it got its system class. So with the help of JDK, we can build our application. And there is a separate concept for OOPS. We will see that, object oriented programming language. We have seen this example now. Every library contains racks. We are considering rack as a package. So just now we have seen here in the base, I have Java. Inside Java, these are all packages. Inside each package, you are getting lot of classes. And inside each class, there are methods. If you scroll down, you can see a method here, like uh, where is the method? Scroll down. Yeah, you see private input stream get in if open. This is a method. We will see this, what is exactly a method, but a classes contain methods. Okay. Now JVM. JVM stands for Java Virtual Machine. Uh, what JVM does, it converts our bytecode instructions to the result or output. So here, if you see this diagram once again, This JVM is responsible to execute the bytecode into the result. Let's say you have you're developing a calculator. You write the code and you compile it and you got the bytecode. And to use the calculator and you're entering some input and output, and that execution is taken care by JVM. Okay. And so Java developer need not to understand bytecode. It's JVM responsibility to execute our bytecode and produce the result. And JVM runs the bytecode, makes the Java platform independent, because in every machine like Windows, Mac computer or Linux computer, we have the JVM, and that takes care of the execution. And it also handles the memory management. We will see soon what is memory management. Okay. And we have Java heap, which means the memory area in the JVM where objects are created is called heap. Okay, let's see how to understand that. So go to this, and normally in a programming, when you uh, write something, right? For example, let me change here. Okay, so normally when you write your program and you say create a class and method. All right. In a C programming or in any other programming, you generally declare something like int num is equal to number 1 is equal to 100. And maybe you declare something like double or float x is equal to 10.5, something like that. So whenever you are storing the numbers or objects, it is stored somewhere, and that location is called heap. Where objects are created is called heap. Okay, but these are not objects, these are variables. We will understand what are objects shortly. And heap is divided into two parts, young space and old space, that we will see.